Okay, so today's lesson, 9.5, is solving systems of linear and quadratic equations. So our learning goal, I will solve systems of linear and quadratic equations. So we now have all of the tools that we need to solve these systems. And really, the three methods that we used for solving linear equations, where we did graphing, substitution, or elimination, those are all going to work when we have one linear and one quadratic equation as well. Okay, so here I have three graphs drawn that can show the different possibilities that arise when you're solving a system of a quadratic and a linear equation. So the first one, we have a parabola, and you see that the line crosses that parabola in two different spots. So because the solution of a system is the intersection points of the graphs, this would be a two-solution situation. So this, we would have two solutions. We could also have a situation where we have our parabola and this line's not exactly straight, like it should be, but where we have a line that just touches the parabola in one spot, we call that tangent. That would be a one solution situation. And then down here you can see we have a parabola, we have a straight line. They don't ever intersect, and they never will intersect. And so this would be a no solution system of equations. So just if you think back to with our linear equations, we had the same thing where, you know, if we had two lines that just intersected in one spot, we had one solution. If we had two lines that were incident, or they were on top of each other, we had basically everything worked, all solutions. Or if we had two parallel lines, we had no solutions. So we have kind of a similar case here with our parabola and our line. So we have three different methods that we can use to solve systems of linear and quadratic equations. The first one is solving by graphing. And so what you would do is you would graph both equations separately. You would look and see where do those graphs intersect, and the intersection points are going to be your solutions, just like I said above when we were looking at the pictures. You want to make sure that you check your solutions when you do that, because sometimes your graph can be a little bit deceiving. But graphing is one possibility. We can solve using substitution, just like we did before, S-T-I-T-U-T-I-O-N. So that would be where we set it up where y equals something and then substitute that into the other equation. I'll do an example of that in a minute. And we can also solve by elimination. E-L-I-M-I-N-A, sorry. There we go, solve by elimination. So those are our three methods that you can do. And really, it doesn't matter which one you use. They all will work. Of course, there are better situations to use graphing. There are better situations to use substitution. It just kind of depends on the equations that you're given. So I'll do just a couple examples, and then you guys really should be good to go. For our first example, we want to solve using substitution. So we're told to use substitution, and in the homework, you are told what to do. For all of them anyway, you're told to do substitution or elimination, that sort of thing. So that makes it pretty easy to decide which method to use. In this case, we have y equals x squared minus 4, and we have y equals negative 2x minus 1. And we want to solve this using substitution. Because these are both equal to y, I could take this and substitute it in for that y. So then basically these are equal to each other. If they both equal y, they're equal to each other. So I have x squared minus 4 equals negative 2x minus 1. So from here, what I'm going to do is I'm going to get everything on the left-hand side so I can set it equal to 0. So I'm going to add 2x. So I have x squared plus 2x minus 4, and that's going to equal a negative 1. And I'm going to add 1 to each side. And of course, you could have done that in one step, but I just broke it into two to make sure you could follow what I was doing. So over here we have x squared plus 2x. I was taking away 4, but now I'm adding 1, so now I'm only taking away 3, and that's going to equal 0. So from here, now I just have a single quadratic, and I can use that, or I can use any solving method that I want for this quadratic. I'm actually going to factor because it looks like it's pretty easily factorable. I need two numbers that multiply to give me -3 and add to give me +2. So 3 only comes from 1 and 3, right? One of them has to be positive, one of them has to be negative. The middle term is positive, so the bigger number is positive. So this will factor to x minus 1 times x minus 3, and that equals 0. So now I know that either x minus 1 equals 0 or x plus 3 equals 0. Those are my two solutions. And I know that because of the zero product property. Remember, we did that way back, I think in chapter 7 maybe? So from here, I can solve for x by adding 1 to each side. I get x equals 1. Here, I would subtract 3 from each side, and I get x equals -3. So I'm only halfway done though, because remember, when we are solving systems, our solution is a point. So I have x coordinates, but I need to find what the corresponding y coordinates are. So I need to take these two numbers and put them each into one of my original equations to figure out what the corresponding y value would be. So that's a box around there. So let's put 1 into my first equation. So y equals 1 squared minus 4. Y equals 1 minus 4. So y is going to be -3. When x is 1, y is -3. So 1, -3 is one possible solution, or is one of these solutions. I'm going to do the same thing with -3. Y equals -3 squared minus 4. That's going to be 9. -3 times -3 is +9 minus 4, which is 5. So my other solution is -3, 5. So if I were to graph these two equations, the graphs would cross at 1, -3 and -3, 5. So these are my solutions. And of course, I could plug both of those back into both equations to make sure they work, but I'll let you guys do that. So here is our second example where we're going to solve the system by using elimination. And it turns out these are actually really easy to do because we already have y's that are equal to each other. So y is going to be super, super easy to eliminate here. So our system is y equals 2x squared plus 7x plus 3. The other is y equals -x plus 3. And you'll notice that when I wrote this out, I lined it up so the -x was under the 7x instead of under the x squared. I don't have an x squared term, obviously, because it's linear, so this is just like having a 0 here. So to eliminate y, I'm going to subtract the equations. So y minus y is 0. Oh, now y is eliminated. That was easy. 2x squared minus 0x squared then is 2x squared. 7x minus a -x is going to be 8x because I'm adding x really there. And 3 minus 3 is 0. So when I eliminated y, I wound up with 2x squared plus 8x. And I think I'm actually going to try and do this one by factoring as well. What I'm going to do is I'm going to factor out a 2x, because if I do that, I'll be left behind with an x and a 4, because 2x times x is 2x squared, and 2x times 4 is 8x. So I took out the common factor, and that was all I needed to do to factor this. So that means that either 2x equals 0 or x plus 4 equals 0. If 2x equals 0, then x has to be 0. If x plus 4 equals 0, then x is -4. So those are my x values, and again, I need to go back to my original equations, pick one of those to substitute in. The second equation, y equals -x plus 3, is going to be much easier to make my substitutions in. So if I substitute 0, I get y equals -0 plus 3, which is just 3. There's no such thing as -0. So one of my solutions is 0, 3. my other solution would be if I put in -4. So y equals -4 plus 3. I get 4 plus 3, which is 7. So my other solution is -4, 7. So these are my two solutions for this system. So this was another one where I had a parabola and a line that crosses. So I have two intersection points. If you want to see an example of maybe where you would have no solution, if you look at example 2 on page 489, what happens is they end up with an equation that looks like this, and then they subtract 6 from each side. So 0 equals x squared plus 6, and then you get -6 equals x squared. You can't take the square root of each side because you can't take the square root of a negative and get a real number. So this would be a situation where you would say there are no real solutions. So just for you to be aware of that example in your book, instead of me going through an entire example, that one will. You can look at that one. Okay, finally, I'm just going to remind you how to solve these on your calculator. So if I had y equals x squared plus 9 and y equals 9, and I want to solve these by graphing, what I'm going to do is y equals, and I'm going to type in my equations, x squared plus 9, and my other equation is just 9. When I push the graph button, let's see if I can see. Oh, I can just barely see, so I'm actually going to change my window. So my y max will be 15. Let's look at that again. Okay, so there's my parabola. There's y equals 9, and you can see they just barely intersect. Maybe, I can't quite tell from the graph. So what I do is I'm going to second, and calc is in light blue, remember, it's above trace, so I do second calc, and then I can calculate the intersection point. On my calculator, that's the 5th option, so I can either go down and push enter or just push the button 5. I'm not positive if it'll be that same option on all of yours, but you should see it in the menu. So first curve, it's saying which equation, which one is your first equation. This would be like if you had 7 different things on here, you would pick which 2 you want. So it says y1 equals x squared plus 9. That's correct, so I push enter. Second curve is my other line. y2 equals 9. That's correct. And guess, it always has you guess. I don't know why. Push enter, and it says our intersection point is at x equals 0, y equals 9. So the point 0, 9 would be our intersection point. So this is an example where there's only one solution because the graphs only touch in one spot. So hopefully you're getting the idea of what we're doing here. It's just using all the methods that we've learned to solve more equations. Your homework is on page 490. You're going to do numbers 1, 2, 6 through 18 even, and 22 through 30. And I didn't say this earlier, but I used factoring to solve both of those equations earlier, or both of those systems earlier. You can use a quadratic formula, you can use factoring, you can use completing the square, you can use whatever you want to solve. The two that I did just happened to lend themselves to factoring pretty easily. So if you love the quadratic formula, then use that for all of them. You know, just do what you need to do to solve. As long as you have it set up correctly, then you're good. So that is chapter 9. You are ready for the test now, hopefully. So get this homework done, and good luck with everything.